In this video, we are going to introduce some basic concepts and fundamentals of NumPy. NumPy is a very popular package for doing scientific computing and also doing like data science, machine learning and AI, and numerical computing, a lot of different things. Despite of its popularity, it is not in the standard library of Python. So you have to install it before you can use it. You can use either pip, or use conda to install it. Or you can use other package manager for Python. So after you have already installed it, you can import it like other module. It is a convention to give this NumPy a short name to be as NP. Although in principle, NP can be stands for a range of different things, maybe like non-profit, number portable, or maybe just like the NP in NP complete, like the complexity things. So it might be arguable it is a bad practice to give this module such a short name. However, because NumPy is so popular and this practice, this convention is so popular, I don't think it is a big risk or you have a big risk to have a confusion of this short name. So people probably, even if you don't give, you just give a piece of code that without the import part. When people see NP does something in a Python code, more often than not, we will assume this NP means NumPy. But this is just a convention. You don't have to do it. And sometimes people does not use short name, just use a NumPy. But I would say like 90% or more, or maybe 95, 99% of code use NP as a shorthand of NumPy. I use it all the time, just saying. So the core part of the NumPy library is the data type, which we call the ND array. The ND array stands for an n-dimensional array. Why do we need a library, a module like NumPy to provide this kind of data type? Isn't that Python already have a very rich collection of data types of a collection data type? Like it has a list, has a dictionary, and in a standard library it also has a DQ or a lot of different things. Why does we even need a third-party library to provide an n-dimensional array? In fact, we can use Python list to have the functionality of an n-dimensional array. So in fact, ND array is kind of like a Python list. It shares some similarity with a Python list. For example, let me construct a simple list like this one, like maybe I put a 4 to 7, or like this one. We can actually convert this simple list of numbers into an ND array. In fact, it is a one-dimensional array. Let me just put this one, 4 to 7, and you get an array. So they look like pretty much the same. Instead, except that they have different type, because this one has an array in front of it, because we convert it into array. But they kind of similar to each other because we can do operations like what we did for a list. For example, we can say get the first element here, then we get the 4 here because this one is the first element, and get the second element and the third one, of course. And we can also get 1 to 2, things like this one, like a slicing. We can do the slicing. Let me make this array a little bit longer, like 1, 2, 3, 4, 5, 6, 7. Okay, and we can do something like 1, 7. Maybe it's too long. Let me just put like 1, 5, and we can also do things like this. So they're pretty much the same. This is because in this special case, this kind of the list is in fact can be considered as a one-dimensional array. And we can also do the assignment also, so say the x is right now 1, 2, 3, 4, 5, 6, 7. And if we wish to change the second element, which is 3, because Python is 0 indexed. So the first one is 0 indexed by 0, and this is indexed by 1, and this one is indexed by 2. So we wish make it to be like 500. And this x, we can modify the content of this array so that the element indexed by 2 becomes 500. All of this thing works pretty much like a list, except what's the purpose of using a third-party library to construct this kind of data type? Why do we need an ND array data type? It must have some difference between an ND array and a list. Yes, they do have some differences. In fact, the ND array has some restriction. Not every list can be perfectly converted or translated into an ND array. So for example, let's say this one, 1, 2, 3, but we put the last element to be a float. If we consider it as a list, it is just a list of 3 elements. The first 2 elements are integers, but the last one is a floating point. If we attempt if we try to convert it into an array, what will it become? You can see that it can still be converted. However, it is not a 100% replication, because every element becomes to a floating point. In the original list, the first and the second element was integers, but after we convert it into an NP array, every element becomes floating point. We can actually convert it back to a list, but you can see that it is not the same thing. So we can actually convert it back to the list, but you can see that every element is become a floating number, which is not a case of the original list. So the reason is that there's a restriction on the NP array that every element has to have the same type. So they can all be floating numbers, all be integers, all be string, or all be other like object. But you cannot have an array that the first element is an integer and the second element is a floating number. So in order to convert as many kind of lists as possible, when we convert a list into an NP array, it will try to convert everything into a type that is as generic as possible. In this case, because floating number is kind of like a real number, an integer can be, if you are considered doing it mathematically, an integer can be considered as a subset of a real number, the real number. It is not case in the computer programming that because the integer is not a subset of a floating number, especially in Python, because of the Python, the integer in a Python is a big integer. It can has the integer to be as big, as large as you wish. It is not the case of floating number. There's an upper bound of the possible legitimate floating number can be represented in a Python floating number. However, I mean, in concept, in a rough sense of the mathematical concept, an integer, a Python integer can be considered an integer, and the closest thing to a real number is a floating number. In the Python world, the closest thing to a real number is a floating number. So it makes sense to consider a floating number to be a more generic type than integer. So they convert the integer into a more generic type. So similarly, if we are doing things like more radical things like this one, like np.array, not only 1, 2, 3, we put it 1, 2 point and to a. So you can see that everything is converted to a string. It is not exactly the string, but say we convert it back into list, you can see everything becomes strings. So this is because at least in some logic, a string is a more generic type that contains more things. So at least we can convert things into a more more generic types. So why does the NP array do this? What is the purpose of doing so? Because NP array is developed to be considered the efficiency and computational efficiency in mind. So like the types in like an array in C, it has to be contains only elements that has the same type. In a Python list, because everything is an object, so the list itself has a more complicated data structure. You can imagine that it considers some point to the object that represent either an object like an integer or floating number or anything. Because everything is an object, so it is just a collection of pointer to the object in some sense. However, if we wish to dealing with a lot of numbers, that will have some efficiency issues because we have to do something to do some computations if we wish to access to the contents of some element. However, if we can assume everything, every element is an integer or like a floating numbers, we can store this data in the memory of a computer in a more organized way. we simply put them one by one because each of the every element have the same size, have the same length, occupy the same length in the memory. So we can arrange them in a certain allocations, in different locations. If I wish to access like the element in the position 1023, maybe just or maybe other position like 1035, because every element has the same size, we can easily compute the location of the memory that store the data of the given the desired element. Then we simply access to that address and we can retrieve that element. And if we wish to update the value of that element, we simply just write the values into the address of that address in the memory. We don't have to move other elements because we have a space dedicated for that or for every element, because every element has a predetermined size. So we can write code to make the computation or operations on this array much faster than we can do for Python list. In fact, Python list is not slow. It's just because it is more dynamic. We don't have much assumption on this list. So it is in principle cannot have some limitation if the speed is our concern. So NP array has a more restricted design, but it can operate much faster than a Python list possibly can. So that's the first restriction of NP array. It must have the same size. So what if we have a nested list? So you can see this one is an example of a very complicated list. It has all the different type of elements. Some of the elements it can be even like a collection type, like a list, like a tuple, or even a map, a dictionary. In Python terminology, it's called the dictionary. So what if we have a if we have a list of lists? Can we convert it into an NP array? The thing is that in some case you can. Of course, it will still following a rule that will convert every element to have the same type. So you can see that if I put the point here to make this one to be a floating number, even other element is integer, it will become an array that contains 40 numbers. But to make things more focused and more simple, let me just make every element to be integer. So you can see that in this case, we can convert this array to be this to be an ND array. So at least some nested list can be converted into a NumPy ND array. However, if I remove this element here, you will see that it becomes error. Oh, sorry. This one is work, and if we put something like more right here, like pen right here, it has error. So what's the difference between the working case and the non-working case? For the working case is that even if every element is a list, I mean, we have a list of lists. So if you have every element to be list, then every element has to have the same length. This requirement is similar to the previous one because we have to make this array to be fast. So we need to have some assumption. If every element is a list, but every element has a different size, then it is difficult to find the address of the element we wish to access, no matter we wish to write or to read. So in order to have a predefined assumption or to have no surprise, we actually want to have to convert some list of lists or nested list into an ND array. But this nested structure has to be very uniform and regular. So the requirement is that at the same level, each element has the same same size. So you can either go further, like we can go like this one, but recall that every element has to have the same size if they are on the same level. So we have to put everything in the bracket here to make it work. It does not work if we didn't put everything at the same level to have the same size. So you can see, like if we put it right here, it works because every list at the same hierarchy or same level, they have the same size. In fact, we have a terminology that called the shape. So you can see that it has a 3-3-1 shape, which means the first level of the list, it has 3 elements, and the second level, each of them has 3 elements, and at the bottom level, which is the inner list one, the most inner one, it only has 1 element. So if I put one more element here, I mean, like say like 0, 0, 0 here. So it becomes 4, 3, 1 because at the most outer level, the list at the higher level, it has 4 elements, and for the second level, we have 4 lists that is on the second level. Each of them have 3 elements, and for each of these 3 elements, they are also lists, but they are lists with just 1 element. We can do further, like if we put this 1, 2, I put random numbers here, but we have to put them. Everything has to have the same length, have the same size. Okay, let me just put one more thing here. So you can see that it still works. So the reason we call this array an n-dimensional array is that we can include any level of nested list. We can convert any level of nested array. I mean, nested list can be converted into an ND array. So the level of nestedness is called the n-dimensional. So this one is actually a 3-dimensional, and the list that only contains numbers as an element, like this one, is called 1-dimensional. In fact, we can see the shape of this one by finding the property of this shape, you can see that it has 3 elements, but it's just one number, so we call it a one-dimensional array. Okay, so the bottom line is that if you are more familiar with a Python list, you can consider that the ND array is a more efficient list, but it has restriction. The first restriction is that every element of this list has to be the same type. The second one is that it can consist nested list. It can convert nested list into an ND array. However, the size of the list has to be uniform in some sense, that the nested list at the same level must have the same size. Another way to see this is that if you are more familiar with the matrix in mathematics, as in mathematics, ND array can be represented like vectors or matrix in mathematics and more. A vector can be considered like a one-dimensional array, and a matrix is actually a two-dimensional array. If we generalize this concept, then we can have a cube of numbers. Then it is a three-dimensional array, and we can generalize these things into a higher dimensional like 4D array, 5D array, and so on. So that's the concept of array. So in an array, because it is a restrict array, so it can be considered as a typed list. Also, comparing to list, it is more restricted, so it can be considered as a typed list in some sense. So when we investigate or study or encounter an array, the first thing we want to ask is what the shape it is and what is the dtype of this array. So I have a comment here. The first thing to look at an ND array is the shape and the dtype. So how do we look at it? We already know how to find out the shape of this ND array is to use the dot shape property. To find out the dtype, we simply use the dtype property. So we can see that in this case, the dtype of this y is integer 32. So it is a sort of integer. It's not a Python integer, because Python integer is very complicated. It is a big integer. And as we mentioned before, that ND array, it has a efficientness in, it's considered efficientness in mind. If they have to choose things, they will choose the efficiency first. So it is not surprised when we convert a number from an NP array into, a list of integers into an NP array, ND array. If everything can be converted into a more efficient representation of a number, of an integer, it will do so. So integer 32 is a 32-bit of integer. Unlike the integer in Python, it has a maxima. It has a maxima and minima. If we cannot represent integers over the maxima or its minima. So what if we convert a list of a number that is too large? So for example, let's see This one is okay because this one is still small. If we put a number too large, it will try to convert it to like a 64-bit integer first. I mean, if we make it smaller, like, okay, this one is just the same using the 32-bit integer. However, if we are trying to make this too large, so that exceeds the capability of integer 32-bit integer. I mean, so what happened? Okay. So if a number is large enough to exceed the maximum capacity of the number that can be represented by a 32-bit integer, it will first try to convert it into a dtype of integer 64, like a 64-bit integer. If we make it even bigger, so that it exceeds the size of the integer 64-bit integer, it will convert the dtype into object. So it will become a big number in just an object. So in this case, because object is a big number in Python, this object is a big number, so it can be arbitrarily large. So that makes you can see that this behavior is not, I would not say consistent, but when we try to convert a list that contains only Python integers, the dtype is not always the same, because it could be an object, could be a 64-bit integer, could be a 32-bit integers. So you have to be very careful. You have to be very careful. I think the root cause is because Python is a very dynamic and object-oriented language. But we are trying to do things more efficient in a more like a C-style sense. So the two different styles kind of conflict here. So when we wish to do things more efficient in a NumPy, we have to be very careful. I don't think the design choice is very wrong. You could have to do something like this is a design choice. When people design the NP array or NumPy, they could choose a design that we must specify the dtype when we convert the list into an NP array, so that we can make no confuse or anything. However, I think their concern might be the convenience, and it works in many cases. But you have to be very careful, because the dtype might surprise you. Sometimes might surprise you. We have already seen some small change that looks kind of innocent or like insignificant, but it changes the dtypes a lot. Like what we see here, like we just put only one thing into like a 40 number, the dtype changes to like float 64. But if we put this one like this one, it will become integer 32. Although they look almost the same. And in this case, maybe they just have a small difference between the number of the, the magnitude of the integer. Like if you consider you are in a for loop, in Python, every integer, no matter it's big or small, they are identical because we always use big integer. But if it is in the range of a 32-bit integer that can be represented. When we convert it into a NumPy array, it will have a dtype like int 32. But if it is bigger, it could become an int 34. And it is even bigger, it will become object. So it will make something, sometimes it will surprise you. So it is always a good practice to do assertion, like assert. Okay, we can do that. Assert, like let's call this x is so if it surprises us, then we will see the assertion error, and we will find out something surprise. Otherwise, it will it will have you cost a lot of your time to do a debug. So I always either have an assertion on the dtype and also on the shape. The shape, sometimes the shape will surprise you also. And also sometimes I just print out the dtype and the shape whenever I can. Because I'm in interactive sort of experiment, it makes sense to print out everything that matters. And I think when we load or construct a NumPy array, I will see the size, the shape and the dtype of this. Sometimes the dtype of this array. Sometimes you may think, okay, it doesn't surprise. Every time it seems like the normal things. So I might want to omit these steps so that my notebook or like my code seems to be cleaner or shorter. But in my experience, if I have any doubt, I will do the assertion or print things out, because it will save me a lot of time. And always do that. If you can, one of the rule in Sum, if you can see something, don't guess. So if right now, like here, I can actually see the dtype, I can see the shape, I will check it. It will cost me like 1 or 2 seconds, but it will save me a lot of time if something surprises me. So this is just some experience and that I can show you. So always check the dtype and the shape of an array. Okay, so here we have some examples. Let me see. Okay. So you can play with this this example in the notebook and see what happens. So you can see that we have shapes and the dtypes. So just play around with this object and get familiar with the NP arrays. Okay, the other thing I wish to share with you is a principle that how do we visualize the content? We already see the type, the dtype and the shape. I'll consider those things as a type of the object, which is kind of independent to the content of it. So different kind of thing. So we already know how to see the type of an object. So after we have already know or understand or determine the type of an object, the other question we have to ask is, how do we see the content? How do we represent the content of that is contained in the object? So one way to do that is to actually visualize using a graph. So I'm going to use Matplotlib to plot these things. So suppose we have an ND array like here. It contains 4 elements. If it is just a one-dimensional array, one way to actually visualize this array is just to plot it, like this one. So you can see that it is a plot that for the x-axis it's corresponding to the index, and for the y-axis it is corresponding to the value that is on the on this index. So the element on index 0, it has a value 10, and this means the element which has index 1, it has a value 2, and this one has a value 3, and this one has a value 4. So you can read the graph and to get all information you need for the value of this NumPy array. And also, on the other hand, if you wish to get a feeling or to check what the value it is, you can plot it in this way. So just remember that there are many ways that you can actually represent the array. There's no single way to do that, but this one is just one way to do that. However, this method only works for like one-dimensional array. For a higher dimensional array, it doesn't work that good. You need to find another way to do that. So let me just do a quick explanation of what this code means. First of all, we import the Matplotlib pyplot as PLT. This is also a convention to call the matplotlib.pyplot and name it as a PLT. We use a PLT plot and put X as the first element to plot this type of graph. The O means each one we have the shape like a circle. If we put this like X, the shape will become X. You can also change the color like red. So I put the R here, so it becomes a red. So I think you might have already tested some design choice of what Matplotlib use, because this one actually smells bad. It kind of like a bad smell because we have something that is semi-reasonable, because like O represent a circle, and the X we got an X here, and the R is an initial of the color red. So it makes some sense, but on the other hand, it also seems like cryptic, because how do we know which things we can use? What if I use something like Y? Does it work? No, it doesn't work, because Y stands not for Y stands for like black, yellow. It will get a color yellow, and you will get something like this one. And if you put something like phi here, it will get something like triangle. It's almost like it is not predictable. Okay, so we have several. We haven't officially started to introduce Matplotlib. We just have a test of it. So in fact, we're going to introduce Matplotlib and we'll explain detail that. But in the meantime, you can use like the document. So for here, because I'm using cursor, or maybe you can use VS Code, that all have similar functionality. So when I hover my mouse cursor over this function, it will give me into some documentations here. And you can actually go to definition or just read document and you can find the answer. Or you can ask. I think use AI. Like I wish to plug X in like black dots. So you can see that it will already show me the result get a black. So you don't need to worry about it. I don't need to read this mistake code of what this string means. I just tell the AI to do it for me. Or maybe I want to like black arrows to the right. Okay, I actually wish to write these arrows to the right, but it auto-completed for me. So, and we ask it to do so. This one? No, I don't think this one works. Maybe I should go the triangle to right. Okay, this is not correct because I already know that it is a triangle to the up, point to up. So it's not working that well. But I think if you give it a more like when I do this control Windows K, Control K, and give a more detailed prompt, it might help me to achieve what I wish to have. So that's just a small footnote. I'm not going to detail to it. Another way to show the result is to simply print it. Here I'm using a library called Rich. So I can have a colorful or more detailed control to the output of a print. So that's one way. But you can also use like the pretty print or use like the original vanilla print as well. Another way is to from let me go to here from pprint. Maybe we can do that like a pretty print. However, I prefer, I like the library Rich, which can do a lot of different things. So that's why I use the Rich here. But like I said in the introduction video, this is very personal preference. You can use other libraries as well. But for me, I like Rich. Some people like when they try to do the progress bar, they use TQDM. TQDM is a very popular library that provides a progress bar for you. But for me, sometimes I will use Rich because Rich is one of the libraries that I prefer to use. But I think this is just a personal test. So you can, this is not a crucial library. You can choose any styles you would like. This is just option that I'm using, often use. The reason that the Rich also works for other data type, and it kind of have a color on it, and it can control a more rich, as the name suggests, a more rich user interface, like a table, or maybe like a text-based window, as if you wish to have. Sometimes it is pretty fun to construct a text-based, like a dashboard in your terminal by using Rich. Sometimes because doesn't require too much code and has a, in my test it has a very pretty user interface. But again, it's not a crucial or fundamental library, so you can make your own decision. Our focus is still on the NumPy itself. So there are many other different ways to construct. Let me check the time. Okay, there are many other different ways to build an array. So one way to do that is np.onceLike. Let me check what our y is. Our y here is an array with a shape 432, and our y has a dtype. The function np.onceLike is to construct a matrix that has the same shape and the same dtype as the given parameter. Here in this example is y. So we can have this one, except all the content is replaced by 1. So as the name suggests, we construct a matrix which has the same type and the same shape as y, but the content should be all ones. A similar function is 0. It's like this one. So we construct a 0 matrix that has the same shape of y. You can also do other things like, so if you wish to construct a constant matrix like y, but every element is 2, then you can do, one way to do that is to do like 2 times np.onceLike y. Then you get what you want. So now you can see that we can multiply an NP array, ND array with a constant. And this constant multiplication will apply element wisely. So every element will multiply by this constant. So originally it is just 1 or ones. So if you multiply it by like 999, it will get 99 everywhere. You can also like doing the same thing but using addition. It will also apply element wise. However, there are, if you only wish to construct a constant matrix, you can use like full np full like. So without doing those arithmetics, you can simply call, okay, well, I wish to have a matrix like y, but fill it with constant. So the name is a little bit strange, but it calls it a full like. There are some versions that you do not have something like, you just simply given the shape. So for example, you can have np1s like this one. The reason that I am using print is, just like I said, I like the rich library. So I'm using this one so it will have a more colorful output. You don't have to use a print, but because I'm import the print from rich, so it will have a colorful output. And you can also specify the dtypes here. Like dtype is like to specify the dtype, you can either use np.like int64. Let me make it a smaller, like, so that we can actually see the dtype. Oh, so maybe it is not a good idea when we wish to see a dtype. So you can see that the dtype is changed. We can choose this to be 32, or maybe we can do this like a float, like 32, or float 64. If you are familiar with C, you may see that in some system it may have something like int 128, but in here we don't have it, and I guess we probably don't have this either. For 96, we don't have these guys. So but I think my autocomplete is not working. Okay, but another way to specify data type is put them in a string. So in case you don't import NP already, and it's just a one-shot thing, so you want to do this only once. You don't want to import NP, but somehow you kind of has the once function from other object also. You can just use dtype is include like int32. It also works, or like int64, or maybe float 64. Maybe you can easily use like but I doubt this should work. Okay, but this works. This is not a very common pattern, but it in fact it works. So you can construct all of them like a string. So you can do that. So you may argue that why do we need the format using to assign dtype to using string? The thing is, you can do that because it's designed to be that way. I can think a few reasons that might help, but the fact is, whether you like it or not, it is designed this way, and I am not remember it correctly exactly, and I don't have confidence. But other libraries, similarly libraries like pandas, like maybe PyTorch, maybe TensorFlow, some of them can use similar way to assign a dtype. Okay, I'm saying that is because I can also imagine that some people may think this type of things is not a good design, because for example, you can do something like this one and it will not work. So it's better to have something like a real things, because you can easier do type inference or other things. It is easier to debug and to do the code analysis. So that's why I was talking about discuss all those things. But if that doesn't worry, you don't have to worry about that. If it is not currently worried about, you are not currently worried about it. I'm just saying, okay, you can. There are some reasons so that things are designed in this way. It can have some benefit in some case. Okay, so another way to construct, there are tons of different ways to construct the matrix, ND array. One way is using I. I is a special kind of matrix. It's a two-dimensional matrix. It can be constructed in other way, but the most popular way to do that is for the two-dimensional identity matrix. So it is a special matrix that only has 0 and 1 as its element. and ones are on the diagonal, and the zeros are otherwise. And the shape of it is 10 by 10 because I'm using 10 right here. You can do something like 2 here. I believe it has some variations that can. I'm not sure. Let me try. I probably should do something like. So it can do something like this one, but in the standard form, it is sort of like square for square matrix. I don't remember whether it can do for a higher dimension, but okay, for a higher dimension it has a different meaning. I don't think it can do. Like it has at most 4 elements. Because this IDE cursor I have just installed on this computer, so I haven't set it in perfectly. So if everything is set correct, I'm expecting when I hover on here, it's going to be get the full document of it. Okay, so it doesn't do it very well. So another way to find out the document is using the Jupyter Notebook way. You put a question mark right here so you can check the document. Because it is on the wrong time. This one is for the wrong time. So you don't need to set up your IDE. This is also going to work well if you are accessing to Jupyter Notebook kernel. So you can use this one to check the document. It is very handy, especially when you is working on a new environment and the document is not already setting. Not everything is already setting correctly. And you can actually check the source code by using double question mark. And so you can actually choose to see the source code of it. You can see everything right here. So and see the explanations. Another way to construct is like NP diagonal here. So it is going to construct a diagonal matrix and using these numbers like 1, 2, 3, 5, 5, 5 as the diagonal. So a diagonal matrix is a matrix that contains all zeros except for a diagonal. So in this case, I put 1, 2, 3, 5, 5, 5 and construct a diagonal matrix with this guy as a diagonal. Okay, so I forgot why I put this 0.1 plus 0.2 here, but this one is a famous example that a lot of gotcha in the floating number format. So even for this type of simple calculation like 0.1 plus 0.2, if you are using a floating number that we use in Python or in other computer programming languages, because this one is actually bound to our architecture in the CPU, so you can see that 0.1 plus 0.2, in fact you will get something like 0.3, 0, 0, 0, 0, a lot of 0 and get 4. It is not exactly 0.3. So there are a lot of considerations about the numerical abilities that may surprise you. And I actually forget why I put these cells right here, because this is a leftover maybe from the last year. But I think this example gives us some reasons that why NumPy is valuable. Because NumPy consists a lot of different functionality and libraries based on a lot of library that has been tested a lot of people and test theory. And like here we see that there are a lot of things you need to concern when you design an algorithm. It may look good and you may even have a proof, but in reality you have to consider the stability of numerical. So sometimes it is very difficult to design those kind of algorithm from scratch. However, because NumPy provides a lot of functionality, so if you can find this functionality in the in the NumPy library, you probably just use it, or because people have already written this algorithm for you. You don't need to worry about things like this one. So there are also a lot of many different utilities to construct arrays. Tons of. Just give a few examples right here. You can use arange. It is an analogy to the range function in Python. So here, let me run it for you. So you can see that the arange 0 to 1. But you can choose the step to be a non-integer one. So this one is 0.1. So you get like 0, 0.1, or 0.2, 0.3 to 0.9. Okay, I remember why I put this guy here, 0.1 to 0.2 here. This is because the NP arange may sometimes surprise you because although we know that if we jump each step by 0.1 and from 0 to 1, it should have like 10 elements in this array, just like this one, 0, 0.1, 0.2, 0.3. However, because this strange phenomena happens for floating numbers, this might not be guaranteed. And sometimes maybe you add a lot of things together. Maybe the semantic of arange is to add things up until we below this number, less or not equal to this one number. However, it is still possible if we add 10 0.1 together. It will very close to 1, but perhaps it will a little bit smaller than 1. So we'll get something like 0.99999, something like here. It is still possible. It is still possible. It is not happening, but I'm not familiar with the floating number, so that I can not sure before I do the experiment. I imagine some similar case, it will surprise me. So that's why we have another function called the link space. It won't have surprise. It means from 0 to 1, we separate like in 10 pieces. So things like this one. Let me do it right here. So you can see that it is equally spaced between 0 and 1. Because it contains 1, so you will have like the 0.1111, 2222, 333 to 1. So if you wish it to have something like 0, 0.1, 0.2, also here we need to have 11 elements. So we start from 0 and end at 1. And if we have 11 elements, then we'll have like 0.1, 0.2, 0.3, like this one. So this is link space. And we can also construct like random numbers, like using np.random. Now this one is going to have uniform random numbers, and we have between -1 and 1, and we generate like 100 random numbers. And using, because this one is just a one-dimensional array, so we use the visualization method we introduced before to plot into a plot. So we can see that it seems like a truly random things. Okay, so let me summarize this session. So this is only a part 1 of NumPy. We have not even done this notebook yet, but let me summarize this session with the following questions. So we can see that array is data stored in a computer. So most of the objects or data type is some data. So first we have to understand what this data is, like what we just do before. We know the type of it. We know the content. We use the print or some, at least for some simple arrays, we can see the content of it. So that's one aspect of understand object or functionality of this. In this particular is ND array, but it is a general principle. However, there another aspect about this object. In our case, is ND array. In fact, there are more aspects. So we can ask, when we encounter a new data type, we always ask ourselves, what information does this data contain? So we already know this answer. We can check it and see for ND array. So what are the restrictions on this data or object? So we see that ND array has some restriction. It has to be sort of uniform in shape, and the data has to be have the same type. And we kind of understand the motivation because they have the efficiency in concern. So what do this restriction means? What is the benefit? If it has some restriction, it must come with some reason. So always ask yourself, okay, we know what it is, but why? Why do it has this restriction? So it will help you to understand why they design these objects in this way. And sometimes the restriction is because it's caused by the difficulty of implementation. And sometimes other restriction is because they serve in some purpose. So if we understand the reason why this restriction exists and why the benefit of this restriction, then we understand this object more. Okay, and next time we probably will cover the next questions, like how can it be used? Okay, we already know the data contains in it, but how can we use this object? How do we access this uses and modify this object? We already see that it can be sort of work like a list. So use some sort of index to access the element, either to read the element or to write, to modify the element. We'll go more for this thing, and we already see some simple operation, like we do a multiplication to a constant, to a number, and do addition of an array. We sum up an array to a number, and we have seen that both of these operations works like element wisely. We'll cover this more next time. Also, there's another method that can help you to understand this object, have you encountered anything similar to before? So in our example here, our ND array, I keep to given analogy of the compare this ND array to a list. I compare the differences and the similarity between a list and an ND array. By using this method, it will help you to understand why this kind of object exists and make you easier to familiar with this object. You may say, okay, an ND array is similar to a list in certain ways. So at least in the slice or index access, maybe even I haven't studied it before, but because I'm familiar with some sort of method of operator on list, maybe I can try the things on ND array to see if they works in the same way. So by comparing the new thing to something you have already known, well, no matter whether they are the same or different, it will help you to kind of position these new things to your mind map. Also, you don't have limit to comparing this new thing to just only one thing. I also compare this ND array to a vector, to a matrix. So if you have other experience before, like for the example, the ND array is also very similar and to the C array. How we use the C array. So if you have some experience in C array, it is also very good for you to understand what the NumPy array is. In fact, you can actually change the layout of a NumPy array by assigning it in a C style or in a Fortran style. So they definitely have something they can transfer together. They have some similarities. When we study the pandas, you can also have some analogy to the things you have learned here in NumPy array, in an ND array, because it becomes all the same when you study the pandas data frame. So after you familiar with the ND array, it will get you easier to understand what the data frame is when you study the pandas. And finally, how can I use these things to maybe to solve my question, some of my tasks, some of my projects, or some to help me to do some real things to solve my issues, what problems I have encountered. How can this guy help me? So if you have these questions in mind, it will help you to grasp the concept and make it concrete, make all the fundamental concept and the object itself, I mean the ND array itself, to be a very useful tools that you can use in the future. Okay, so that's pretty much it for the things we are going to talk about today. Okay, so see you next week.